So I want to talk a little bit about the power series expansion of the sine function. So if we have the sine function, can this thing equal to some power series or some polynomial that looks something like this? And as it turns out, yes it can, but it's not going to have a termination point. And so in other words, it's going to be of infinite order or infinite degree, wherever you want to call it. So let's just assume that it does have some expansion like this. Alright, so we know that sine of 0, well, then this guy, this term's going to go to 0 because we've got 0 here, and all these terms are going to have a factor of 0, so sine of 0 had better equal to this constant here called a0. So, well, we know what sine of 0 is. Sine of 0 itself is 0, so 0 is equal to a0, and actually I'm going to do like a little table here. So a0 is going to be 0, and a1, a2, a3, and a4. And this will be enough for us to see a pattern, hopefully, and if not, I'll just expand it out a little bit. So let's differentiate this thing. So sine is going to go to cosine. So cosine of x is going to equal to, well, this is just going to disappear. This is going to become a1 plus 2 a2 of times x. So this is just the power rule for differentiation, plus 3 a3 x squared plus 4 a4 x cubed, and so on. Alright, and again we're just going to do the same thing. So cosine of 0, all these terms here are going to cancel, so we're just going to be left with a1, and we know that cosine of 0 is just equal to 1. So a1 is equal to 1. So let's differentiate this thing again, cosine. So that's going to go to negative sine of x. And on the right hand side here, this a1 is going to disappear, and we're going to be left with 2a2 plus 3 by 2 a3 plus 4, oh, this should be a3x, sorry, plus 4 by 3 a4 x squared, and it'll be 5 by 4 a5 x cubed, and so on. So negative sine of 0 is going to be, well, all these terms again, they're all going to go to 0. So this is going to give us 2a2. We know that this is 0 anyway, so a2 is going to be 0, and why not, we'll just do one more. I'll just make some room first. We don't really need this anymore. And I'll just move this up. Alright, so we're going to go negative cosine of x. And this is going to go to, well, 3 factorial a3. So it's going to be 3 by 2 by 1 a3 plus, we're going to drop another power here, so it's going to be 4 by 3 by 2 a4x plus 5 by 4 by 3 a5x squared, and so on. And negative cosine of 0 is going to be equal to, well, all these terms here on the right hand side, they're all going to go to 0, other than this first one that we have right here. And actually, instead of writing this as 3 by 2, I'm going to write this as 3 factorial a sub 3. And we know that cosine of 0 is just equal to 1. So we get that a3 is equal to 1 over 3 factorial. This should be a negative, sorry. I know I was missing something there. So we get negative 1 over 3 factorial for our value of a3. And as you keep on going with this little game thing that we have here, you're going to find that, if I make some more room here, that you're going to find that your sine of x is going to look something like this. So we have a0 is 0, I'm going to write it in anyway, plus on 1 over 1 factorial times by x plus 0 x squared plus, sorry, this should be a minus 1 over 3 factorial times by x cubed, and it's going to be another 0 here. And you're going to end up with this sort of alternating odd power series. So this is going to be x to the 5th over 5 factorial. And this is going to continue to go because when you differentiate negative cosine, you're going to wind back around to sine, and then it's just going to be a cyclic series of derivatives, I guess is the way to put it. And so yeah, so we get in the end that sine of x is equal to this infinite sum of x, it's going to be over the odd factorials, so it's going to be over 2n plus 1 factorial if we're starting from n equals 0. And, well, the powers of n are going to be x to the power of 2n plus 1. So, and this is to infinity. And this is actually a really good representation because you can see that if you plug in, it sort of inherits the expected properties of the sine function that you'd expect. So if you put negative x into here, then this is just going to change the sign of the entire function. And yeah, so this is a pretty nice little series that we have here. Thank you for watching. Like and subscribe if you enjoyed this video. Let me know how I can do better. And yeah, peace.